Okay, so in this video I am going to demonstrate to you a web application that is about data flow analysis of graphs, which can be used in the context of white box testing. Earlier we studied about the control flow graph, and the web application demo I introduced in one of my earlier videos was about the analysis of control flow graphs on the basis of different coverage criteria. And in this case we are going to do a similar analysis, but in this context we are going to use the data flow analysis and data flow coverage criteria. So this web application is developed by Professor Paul Amman and Jeff Roberts group, and it can be retrieved from this link which is on the top of this browser's address bar. I will also provide this link in the description. And just like the control flow graph web app, this web app has also certain input sections. First one is this in text area, where you can provide inputs about the graph edges. Then in the next section you can give the initial nodes or a single initial node of the graph. If there are more than one initial nodes, then those have to be input into this box, but they must be separated by spaces. Then in this part of the web application you have to provide the information about final nodes, and if there are more than one final node, then those must be separated by a space and entered into this text box. Since this is a data flow coverage analysis web application, so we also need to provide data definitions and data uses, and data defs can be provided in this text area. And the mechanism which you can use is that you just need to mention the variable for which you want to provide the definitions. So that variable must be written first, like here, and then all the definitions which this variable has in the graph on the nodes must be provided afterwards, separated by spaces. And then finally we need to provide the uses of the variables, and those can be provided in this section. And like the defs, this must also be done in the same pattern. You have to write the variable first, and then all its uses in the graph separated by spaces have to be provided in this part of the application, web application. And then so now let's work out an example by means of this web application. So I also explained this example in my last video, so let's try that again, and now we will do this practically. So in that case sorry, the graph had the initial node. This was connected to node 2 and node 3. These two nodes were connected to node 4, and node 4 was connected to node 5 and node 6, and these two nodes were connected to node 7, which also happened to be the final node of this graph. We had a definition of x on node 1, like x equal to 42. We had a use of x on node 5, z equal to x times 2, and we had a use of x on node 6, it was like x minus 8, something like this. Now we have one definition of x and two uses of x on this graph. So now we need to input this information of edges and depths and uses to different sections of the input section of the web application. So let's try to do that. First I need to input the edge information of this graph, which I can do in this section here. I have already copied this information on the clipboard, so I will just paste by making use of Ctrl and V. and then in this section I will provide the initial node, which was 1, and then in this section I will provide the final node information, which was 7. So that's done. And now I need to provide the definitions of any variables, which in this case is x. I need to write the name of the variable, which is x. I need to provide the node where it has a definition, that was node 1. So that's done. Now and I need to provide the uses of this variable. So I have to do this here in this box. The variable is x and it is being used at node 5 and node 6. I have to separate both these nodes by means of a space. So now the information of the graph is done. Now I have to do an analysis on the basis of depths and uses of these of this variable. So let's try to do that. So for that I would like to erase all the ink on this graph so this becomes a bit clearer. So now you can see here I can compute the test requirements for def use pairs and def use paths, and then I have these different coverage criteria: all defs coverage, all uses coverage, and all due paths coverage. By clicking on these buttons I will be able to find out the desired results. So for example, if I want to compute the due pairs, I just need to click on this button. So here you can see it lists these two due pairs, which are 1 5 and 1 6, and it is obvious from the graph. We know that there was a definition on node 5 and node 6. Therefore there are two def clear paths from node 1 to node 5 and another one from node 1 to node 6. Now if I want to compute the due paths for this variable, then I just need to click on this button, due paths, and now you can see there are 4 due paths listed, and these paths start from node 1 and go to the two uses of the variable x at node 5 and node 6. Since they are crossing at node 4, so we have two options for each path. Either we go from 4 to 5 or we go from 4 to 6. So this gives the possibility of each use to be reached from node 1 in two ways. Now if I want to compute the test path for all test coverage, then I just need to click on this button, all def coverage. So I do this, and as we studied in the last video, that we can cover a definition if it occurs on any path just once. So for example, the definition is on node 1. So this node had a definition of x. Now if we traverse this path 1, 3, 4, 6 and 7, so in this case this def reaches this use of x on node 6, and since as it is a test path, it must begin from node 1 and end at node 7. But in any case, by writing any one of those paths, we will be covering this definition of x on node 1. Now if I want to compute the all use coverage, then we have to cover at least the use with one of the parts. So since we have two uses, so we will need at least two parts. So to compute the all use coverage, we click on this button, and now you can see that we have two paths, test paths listed, and I can mark these on the graph. First path is 1 1, 3, 4, 6 and 7. So this basically covers the use here, use of X on node 6. And the second part, let me change colors for that. So that takes 1, 3, 4, sorry, that is 1, 3, 4, 5, 7. That is 1, 3, 4, 5 and 7. Now this part actually covers the use on node 5. So we have covered all the uses by means of these two parts. So that's why this fulfills this criteria of all use coverage. Now the last criteria was of all due parts coverage. For that I need to click on this button, all due parts coverage. I just do that, and now you can see we are listed with these. So we are listed with these 4 parts. So these 4 parts are the all potential possibilities that take you from node 1 to node 7, and they alongside they visit these node 5 and node 6, which have the uses of the variable X compared to the definition on node 1. So let's try to mark these. First one is 1, 3, 4, 6 and 7. I am changing colors for the second. So that is 1, 3, 4, 1, 3, 4 and 5 and 7. And for next one I again change color. So that is 1, 2, 4, 6 and 7. And the last one is 1, 2, 4, 5, 7. 1, 2, 4, 5 and 7. So in this way we can cover all due parts coverage by means of these 4 paths on this very simple graph. So in today's video I explained or I demonstrated you this web application which is provided for doing an analysis of defs and uses of a variable, and you can do different sorts of analysis like the all def coverage, all use coverage and all due parts coverage. So thank you very much for your time, and in the next video I will be coming up with the coverage of logical specification. Thank you.